open this study. Okay, now this study, I'm going to blow this up so we can see it. Okay, let's look at this data. This data represents the mortality rate for females in 1992 in Sweden and in Kazakhstan. Okay, so here we have the population of females in Sweden. Okay, we have it grouped by age here very conveniently. We have a total of 4,385,000 females living in Sweden at that time, and 46,000 of them died during the course of that year. And Kazakhstan, we have a larger population of females. We have 8,708,000 at that time, and 64,000 of them died. And we're going to calculate the crude mortality rate. Well, the crude mortality rate is equal to 46,000 over 4 million, and that's what this number is. Okay, it's expressed as a fraction. It's a little over 1%. Okay, now the crude mortality rate for females in Kazakhstan is 64,000 over 8,700,000, comes out to be 0.007 or less than 1%. So the way it appears now, a higher percentage of females died in Sweden during that year than in Kazakhstan, even though life expectancy for females in Sweden is 81 years and in Kazakhstan is only 68 years. Does that make any sense? I mean, that seems really contrary to logic, doesn't it? Doesn't make any sense. Okay, well, let's take a closer look at this stuff. Okay, again, I'm going to blow this up so we can see it. Okay, so now let's take a look at this. Okay, we had the number of deaths in Sweden, just as we calculated before. Sure enough, 1%. And your chances of dying if you're female in Kazakhstan was only about 0.75%. It's lower. That's the crude mortality rate, by the way. One of the ways we might express this instead is to take this number and multiply it by 1,000 or 10,000 or a million, times, okay, and say it's 10.5 females per 1,000 died. And over here, do the same thing. 7.5 females per 1,000 died. Well, same thing as saying this proportion, except there's a little bit more manageable number. Sometimes easier to just leave it as a proportion when you're calculating things, but when you're reporting it, it really helps to put the numbers into perspective. But we still got the same result here. Okay, so now let's take a look at our next step. Okay, so now I'll blow this up again so we can see it. All right, so let's take a look at this. Let's take a look at the death rate individually within each one of these age ranges. Okay, so let's see. We have between 10 and 14, 33 women died in Sweden out of 240,000. So the rate of death is 0.14. Actually, it's much lower than that. That's times 1,000, 0.14. Okay, and the rate of death measured the same way times 1,000 is higher in Kazakhstan. Well, how about among 40-year-olds, 40 to 44? Well, for Sweden, it was 1.17. For Kazakhstan, it was, 2.8. Okay, for 65, it was 12, 26. For every age group, the rate of death was higher in Kazakhstan than it was in Sweden. And yet, we still got a crude mortality rate that was higher in Sweden than it was in Kazakhstan. Well, why is this occurring? Okay, this is just so you can see it a little bit more readily. We isolated I don't remember where this data came from. We managed to accumulate it from somewhere. I've been doing this for so many semesters that I forget now. But you'll see that here's the death rates, age-specific mortality rates, age-specific ASMR, age-specific mortality rates for Swedish females and Kazakhstani females. And you'll see that every one of the age groups is higher. death rate's higher. Okay, even though as we said, crude mortality rate is lower in Kazakhstan. Okay, so let's blow this up and take a look at it. Well, now let's take a look at this again. One point, this is, okay, let's take a look at how the population is distributed. Okay, what percentage of women are over 80? Let's see, there's 3 and 2.5. About 6% of the women in Sweden are over 80, while only 1.5% of the women are over 80 in Kazakhstan. Well, how about 55 to 50 to 55? 5%, about the same. But then as we get older, look how drastically this reduces. In other words, and let's look at younger. Well, 5% of the population, or 5.5% of the population, is between 5 and 9 in Sweden, where 10% is that young in Kazakhstan. So the mortality rates are much lower for younger people in either country compared to older people. So what's happening here is that we're applying these age-specific mortality rates, but the ages of people in the women in Kazakhstan is much younger. The population distribution is much younger than it is in Sweden. So even though they're dying at a higher rate in every age group, it appears that the mortality rate is higher in Sweden than in Kazakhstan. It's just that they're so much younger that it makes it look like a mortality rate that's more significant in Sweden. Okay, so now let's see how we're going to correct for that. Okay, so now we're going to use something called standardization. The problem here is that we know the rate at which these women are dying. Here's the age-specific mortality rate for Sweden. Here's the age-specific mortality rate for Kazakhstan. If we could just apply these rates to the same population, we, instead of two different populations that have different distribution, we've had a much better idea of where these two countries really stand in terms of female mortality. Okay, so we need to find a population that we can apply these rates to that's the same for both countries. And there's a number of ways we could do that. One way we can do that is to find a third country, which is somewhere in the same region, and use that country as the population that we're going to apply both of these mortality, age-specific mortality rates to. Or in this case, what we did was we just said, okay, let's add the two populations together and make believe it's a single population that's the sum of both of them. Okay, so instead of 59,000 women, 59,000 infants in Sweden, 100, almost 200,000 in Kazakhstan, it's like 250,000 in a single country, which is the meld of both of them. Okay, let's see if I apply the age-specific mortality rates for Sweden to this single population that we're going to use as a standard, right? It's 4.71. It's actually 0.004 if I forget about that times 1,000 times 243,000. At that rate, I would expect 1,000 women. Notice F3 times D3 divided by 1,000 to get rid of 1,000. That would be the number of women, the number of infants we would expect to die if they were dying at the rate that they do in Sweden. If they're dying at the rate that they do in Kazakhstan, that same 233,000, we would expect 5,000 deaths instead. So we calculate the expected number of deaths given the rates in each country using a single population, and now we get a total of 83,000 that we would expect to die in this common population. If we use the rates for Sweden, age-specific mortality rates for Sweden, and 83,000 over the population of 13 million gives us an age-adjusted mortality rate of 0.006 or 6, if I move that over three places, 6 per thousand, or 0.63%. If we do the same thing for Kazakhstan, we get 135,000 expected deaths over 13 million, gives age-adjusted mortality rate of 1.05. So if these two populations now age adjusted so that they're applied to the same population, we see that women in Kazakhstan are dying really at twice the rate that women in Sweden are dying. during the course of that year. So that's how we do age adjustment. We apply the age-specific mortality for each group to a single common population so we can get rid of that variable, that confounder, which is the differences in the distributions of younger and older women. Okay, how does that come across? You guys understand that? I'm going to give you guys an example of that to work out on your own using Excel. I'll set it up on steps like this to kind of help you get through it, and hopefully that will make some sense to you. Now, I'm going to wait until tomorrow night to put up homework number 2, which is going to be an SPSS example and an Excel example that you'll work out to calculate a age-adjusted mortality rate. Because by then, I hope by tomorrow night, or maybe the latest Wednesday morning, that I'll also have the videos available for you so that at the same time you'll be able to go back to this video and visualize how we did this stuff as well. Okay, so it's getting late, and we're already 10 minutes past where we should be anyway, because we ran a little late tonight. So is everybody okay? And hopefully things were a few glitches here and there, but I think overall things worked out pretty well considering the fact that we had over 50 people that got together on this on the internet and did a class, and we were all able to stay comfortably at home or wherever we were. How many of you are any of you right now in the lab back in C05? I know a couple of you people had other classes and thought you might be hanging back there rather than trying to rush home for these classes. You're at Hunter, but not in the lab. Are you using your own laptop somewhere on Wi-Fi? Hager? Oh, okay, good. So then we know that works too. I had someone test that yesterday, and a couple of right. I had someone test that yesterday in the lab, C05 this morning. Test that, and you can use the computers down there. You don't have to be an administrator to get it to install and work. You just have to remember to bring a headset or a pair of earbuds, because I'm not sure they have speakers there, or even if they did have speakers, I'm sure they wouldn't let you, blast them as everybody else was trying to use any machines there. Okay. Hopefully, they actually have those still reserved for us. Okay, so have a good night, guys.